the A part of the A part and B part of this question. In this part, I'm just going to focus on the C part of the question. The C part of this question is asking, calculate the value of the loop gain A beta, hint set Vs is equal to 0, and break the loop at the base of Q1. Simplify the circuit by eliminating DC sources. Okay, so here we have the circuit right here. We can draw the small signal equivalent model, and this is a BJT. You know that it has a collector, base, and the emitter. So we know that if it's MOSFET, we have GDS like gate, drain, and source. If it's BJT, then we have the phi model that looks like instead of gate we have the base right here, and then instead of collector we have the in the BJT we have GDS, that's gate, drain, and the source. In the BJT we have base, collector, and the emitter. So B, C, E. Okay, that's what we have to remember. Other than that, we have to just we can just draw the circuit. Okay, so let's draw the circuit. We have two BJT connected. First BJT right here, and the second one is connected with the collector of this one, collector of the first one. So the circuit is going to look like this. Okay, so this is base, collector, emitter. Okay, and if you look at the emitter of the second one, it has a lot of them. Okay, so let's simplify the circuit. Let me see. Okay. So first, this is the input voltage. That is, let's call some VT, the input voltage, and here we have the resistor. Let's call this one RI1. Okay, and then here we will have the current flow in the collector. That current in a BJT, we express that one in terms of a current source, that is beta times IB. Okay, and for the base of the second BJT, this is beta IB. For the base of the second BJT, we have RI2 resistor right there, and there's also a current flow, that is if I call some beta IB1, this is beta IB2 right here. Okay, and the current through this one is the IB2 current, and here we have the emitter resistance, and in the emitter there's another resistance RS also right there. We have to consider both of them. This one is RE1, and also we have the RS connected as well. Okay, and Vs is said to be 0, so it's grounded as it mentioned here. And if you look at the emitter of the second circuit, here we have R1 resistor and R2 resistor parallel to each other, and there's a hidden resistance, that is R in 1 as well. So let's put the R in 1 over here. Ground it. And here we need to have parallel resistance. So I'm going to put a line somewhere here. And here we need to have a resistance R1 and R2, both of them are parallel. So we have R1 and then R2. Okay, and then we have the load resistance here as well. RL, and those are all the resistance. Nothing else, so we can make this one, remove this one. And here at the end we have the output voltage. We can say this is output voltage right here. Okay. So this is the circuit, and at this point we have the VR voltage also there. Okay, so that's all we have to know. Once we have this one, we can derive some expressions. First we consider our input 1, that is this one. That is nothing but this RS resistance plus the emitter resistance right here, that are RE1, plus this R1 parallel to R2 divided by 1 plus beta. We can call this one equation number 1. We are creating the equation because we need to know this R in 1 value in order to solve for A beta. That's the one we are trying to find. The main purpose of doing this is we are trying to find the loop gain A beta, which needs this all the resistance value. We need to know R in 1, also we need to know the RE1. So we have to find out all the values. That's why this equation is helpful. Now here, if you look at this one, here we have RS, that is readily available with the question. RE1 we don't know. R1 and R2 are available in the question that's provided. Beta also given in the beta. Yeah, beta also provided. Both of the betas 100. So that's also available. So only value unknown is RE1. So we have to calculate this one. This RE1 is nothing but this is the emitter resistance that can be calculated using the thermal voltage VT divided by the current IE1. This IE1 current we calculated in the part B of the question. In the part B we did the DC current, DC emitter current for Q1 and Q2. If you don't know how to find the emitter current, you can watch my previous video. But we found out the values of IE1 and IE2. Since we are interested in finding RE1, for that one we need the IE1, which is we calculated to be 83.9 microampere. So VT is thermal voltage, that is always 25 millivoltage, and IE1 we already calculated in the previous part of the section, that is 83.9 microampere. And if you calculate the RE1, that comes out to be 297.97 ohm resistance. Okay, once we have the RE1, we can now go ahead and find out the R in 1. We have to just plug in plug in the values. So I'm going to copy this equation and bring it to the next page. Okay, so now this equation we have to plug in all the values. So here RS is, if you look at the question that is mentioned, 100 ohm resistance. So 100 right here, and RE1 we just calculated 297.97 ohm. 297.97 plus this R1 and R2 values also provided, that is 1K and 10K. So 1K parallel to 10K divided by 1 plus beta. Beta value is given 100. plug in all the values and calculate for the R in 1 value, you will end up getting 398.06 ohm resistance. Okay, now we have the R in 1 resistance, and also we have the RE1 resistance. Now we can go ahead and find out the beta, A beta, that is the loop gain. Okay, that is provided, that's the loop gain A beta. So this A beta is nothing but negative VR over VT. So we have to find out this VT voltage and also this VR voltage right here. If you find out both of them, then plug it in, that's the A beta, and also we have to include a negative sign to it. So first, if we start with the VT, this VT is nothing but this VT is right here. That is 1 plus beta times the IB1 times this RS and RE1. Okay, so 1 plus beta times IB1 times RS plus RE1, and this IE1, this 1 plus beta IB1 is nothing but IE1. IE1 is equal to 1 plus beta IB1. So what we can do is, instead of this whole term, we can put IE1 for it. So this VT will become IE1 times RS plus RE1. Okay, the next thing is we can consider an expression for the output voltage VO, that is over here. This VO is nothing but the emitter current in terms of we can also express as one in terms of emitter current, that is beta over 1 plus beta times IE1 times 1 plus beta times the resistance that is parallel. In this case, R1 and R in 1 are parallel here. So this one is R1 parallel R in 1. And that one plus R2. And that one parallel with the load resistance. You look at the circuit, load resistance, so parallel. So parallel to load resistance, that's the output voltage. And here, this IE1 also can be expressed as VT over RS plus RE1. So instead of this IE1, we can replace it with this. So if we do that, then this equation becomes beta over 1 plus beta. Instead of IE1, we plug this value, that is VT over RS plus RE1, and then 1 plus beta times R1 parallel Rin, and then plus R2 parallel the load resistance. Okay, now why we need this one is because in the VR expression we are going to have the we know the VT, but we don't know the VR yet, because we need both of them in order to find out the closed loop gain, which is A beta. Okay, that's the question is asking for. um, let's say loop gain. Okay, so loop gain is a beta, and in order to calculate a beta we need both of them. So this VR expression is nothing but that is R in VR. We are looking at this voltage right here, the voltage across the R1 resistance. So this is nothing but the R in 1 parallel R1 times the output voltage divided by R in 1 parallel R1 times plus R2. Okay, and instead of this VO, now we have to plug these all terms. So that's going to be a very big equation. So now we are going to have VR to be the term we put first, which is R in 1 over parallel R1 over R in 1 parallel R1 plus R2. R in 1 parallel R1 over R in 1 parallel R1 plus R2 times the VO, which is the whole term we have right here. That is this whole term. So I'm just going to copy and paste it over here. Okay, so this one multiplied by this whole term. Okay, to show multiplication I put a bracket for it. Okay, so that is the whole term, and in the whole term, if you look at this here, in this one we have the VT, and here we have the VR, and this A beta is nothing but negative VR over VT. A beta is negative VR over VT. We have the expression for the VR, and this VT right here. If I bring this VT to this side, then this equation becomes VR over VT and that is equal to R in 1 parallel R1 divided by R in 1 parallel R1 plus R2 beta over 1 plus beta. You know, instead of writing all this, I could have done one thing. I can select this whole thing, copy and paste. Okay. Okay, I need to copy this one as well. Okay, and now what we are going to do is we are going to bring this VT this side, and if we bring it, this one become 1. Okay, and if you as you notice, this is not the expression where this is Let me double check the VO expression. Yeah, in the VO expression I made a mistake that when we are having this VO have a negative sign in front. Okay, this one has a negative sign. So this one has a negative sign, which means this one has a negative, which bring the negative to here, negative to here. A beta is negative of this one, so if we put a negative, negative cancel, and the positive value of this one is going to be the A beta. Okay, so let's go and express this in the next page. So A beta is nothing but negative VR over VT. So this one is VR over VT, and if we add negative to this, that will remove the negative sign. So let's try to copy this one. Okay. We can say this is equal to A beta, and the negative sign is gone. So once we have this one, now we have to plug in all the values we have and calculate the final answer. So here R in 1 is ready. We've just calculated that one to be 398.06. Plug that one in. Parallel R1 is 1K. Again 398.06 parallel 1K, and R2 is 10K, and beta is 100, and the RS value is 100 ohm resistance, 1 over 100, and the emitter current also emitter resistance also we found out that is 297.97. So plus 297.97 times 1 plus beta, which is 1 plus 100, times the R1 is 1K, parallel Rin is 398.06, plus R2, which is 10K. Okay, and multiply everything and calculate the final answer, and you will end up getting the A beta value to be 6.92, and that's our loop gain. And that's it for this question. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.